Hi, welcome to another very quick Great Car Basic demonstration. So I'm going to show you I2 message queue using a couple of devices, and we're just going to show you how we've got a slave working. So it's really a slave IC2 implementation. So very quickly, I'll show you a camera. Just leave it running, right? Okay, so you can just see what's going down, right? Okay, so look. I2C is communicating down this. I mean, look what it is. It's a clock line between and down this data line down here. I mean, it's quite fast, reliable, and most importantly, it's addressable. I can have 128 7 devices hanging off of this, what's called a master. That's using 7 bits. You can have more, but we just don't support the 10 bits addressing. So we're not going to go into I2C in any great depth. There's lots of resources up on the web that you can have a look. Okay, all right. So what we've created is a master in this 16F 690, and this is a slave. This is the new, what's the new, relatively new, what do you call it? The Express board. Okay. And this is quite easy to program. That's very easy. But to program this is a bit trickier because the master does all the initiation of the talking generally, but the slave actually doesn't initiate the talk. It has to listen for events, and it has to be responsive to those events as much as possible. So yeah, we use events inside of this little tiny chip here, inside the it's a 16F 18855, and what I've done is taken the an implementation of a JAL implementation and ported it across to a GC Great Car Basic, and added in a lot more features, of course. Right now, you can go and have a look at the app note on the Microsoft website, AN734. That gives you some great insights into what's going on inside this in the communication here. But as you can see, look, what's going on here. Look, there is 4 LEDs on this board, and they are chirping away. Look, one. You can see there's one, and it's counting in binary. Look, let me just count that through. Look, 15, 0, 1, 2, 3, 4, every second. Okay. So what's going on is this: the master is it has a number of states, 5 states, and it's either writing data, where that data is talking to this chip. It's writing data where it's got an address. It's writing, doing some read, etc., and it's communicating between itself and the slave. But what's really important is that the slave has 2 addresses. It has the what's called the write address and the read address, and you need to go and sort of sort. You can look into that yourself, how that actually works. Okay, but what's going on is that the protocol is actually handling the communication between the 2. Okay, so this master is talking to this slave. Okay, so we need to check out that this is all operational. So what I'm going to do, I'm going to go into Great Car Basic, and we're going to run some code. Okay, so I've got some example code ready, and look, we're going to use software I2C discovery. Why am I using that? Because I'm going to discover what's on the bus. Okay, this is this is what's called the bus. This is the connection between these 2. Okay, now I've taken a standard demo, and it's a Great Car Basic demonstration, and what I've got connected up is I've got the 690 hooked up to a serial port. Okay, through a TTL. Okay, we can look at the camera. Yellow line here is going off to a TTL. Okay, all right, and so I can prove it to you. Like his piece of code here, it's an F690. We can say, oh, we can okay. Never do live demos, but we'll do a live demo. And we'll get a live demo. Okay, and what I'm going to do is I'm going to program that, and what this is going to do is just do a standard figure out what's on the I2C bus. So pick kit is hooked up. Let's have a quick look. There's the end of the pick kit there. Okay, so we're just going to check out that hardware to make sure everything's operational. And essentially, this I'm not going to touch the slave at the moment. We're going to come back to that. Okay. All right. So that's just programming that. And over here, oh look, You just saw some stuff in here. It says like live demo. Oh, it's got z behind it. Oh no, I'm not quite sure why it's done that. Oh, it's because it's software, I bet. That's right. There was an interrupt coming in down on there. So if I just press the reset button, look, what I'm saying, right, okay, is that these are all the possible addresses, 00 through to FF, right? Okay, they're not all addressable, but you have to work that out on your own. Okay, so I've got two devices. I've got one sitting on 40 and 41, write address and a read address, and I've got another device on 70 and 71. So we can see really quickly that that's working. Okay, if I take the wire off, why don't we do that now? Okay, we'll just check the connectivity. What line shall I take off? I'm going to take off. I'll take off this line here. Okay, pull it to take it off and get down there. All right. Back in here, press the reset. Nothing, because we know it's broken. I'll put the clock back on. Alright, the clock goes back on, and I've lost something because I did it mid-string, right? Okay, but look, it reappears. So, where's that coming from? 4041 is from the slave, what we're going to be looking at, and we're going to change it in a second. 70 and 71 is. Oh, I can't change it here, can I? Yes, I can. Of course, I can. Is actually a temperature gauge. Okay, so let's have a look what we've got down here. Alright, what have I got on this? Oh, I know what I've got. Installed in here, I've got something called controlled LED, and this is the slave controller for the LED. Okay, we'll come into what that looks like in a moment. Okay, but essentially, look, it's got a standard, looks like a standard program, and it's got just a couple of functions in there, the methods that you have to do. All right, and this is the address here. Look, you have to set the address and tell it it's a slave. They're standard Great Car Basic things. So if we want to change that to 30, I don't know, 38, whatever we want to change it to, we simply reprogram this thing. Okay, so we'll just generate a hex file. Now I'm generating a hex file for a particular reason, because this is a express board. So once that's compiled, okay, it's compiled it up. Look. I've got a new hex file in here. Look. That's the time now. I'm just going to send that over to the. I'm going to send that to the express board. Okay, all right. And hopefully that's gone in there. I'm just going to do that again because I'm not convinced I sent it. I can't see the screen at the same time. Oh, it is on there. It's definitely on there, isn't it? Yeah. Okay, so what have I done? I've changed the address. Okay, just to prove to you guys that it's working. So I'll come back to the terminal. I'm going to press the reset button, and look, it's moved to address 38. So something is controlling the address. Well, it's as simple as changing this line here. So I'm going to put that back because that's like sort of important. I just tried to program it. I've just done a really silly thing. I tried to program the express board via the pick kit. Okay, so I may have to reprogram the. It might barf out. Okay, great. It barfed out. So I'm just going to copy that code back to the express board. Tell it to overwrite it, and then I'm just going to come back into here, and we're just going to see on the preview, on the screen here, the search look. Yeah, you know what? I blew away the code that was inside of the discovery because I turned the PickKit 2 off. The power. That's what I've done. I turned the power off to the PickKit 2. Back in here. Oh, look, it's gone back to 41. So we're back where we started. So there's something going on in the slave, and I'm going to have a look at that. Okay. And the slave has got a couple of things in here, and that's all you need to worry about. It's really quite simple. You've got your user code, you've got the preamble, right? Preamble, all about setting stuff up. Just look at that in your own time. There's nothing special about that at all. The only special thing is you have to set the address and set the mode to slave. Cut the variables. I'm only using those local variables. They are not important. I could delete them. And in here, I've just set flashy LED. So in actual fact, when I do start this thing up, if I press that reset button on there, you will see the LEDs flash, but flash. That's just to make sure I can see what's going on. And in here, you can do all the normal stuff. That is your user area. But we're talking about the slave. So the slave's an interrupt, and essentially the data comes in a buffer, and we're going to read the buffer. We're going to say what is inside of a buffer element 0, and if it's number 23, then I want you to take the value out of the buffer number 1, and I'm going to set it onto the port. So whatever comes in gets set to the port, and that is it. That's all that's in this code. There's this error handling, the flashy LEDs in case it goes over buffer. You don't need to do that, okay? I've put that in because look, I've added that in. You don't need to put this in. I can delete that, and this will still operate quite happily. Okay. This is the only important function. Process manager. Okay. Process in message. It comes with the size of the packet that came in, and in our case, it will be 2. I know that the first byte of the message in I2C is in buffer 0, and I know that the command I'm looking for is in buffer 1. So if I look down at the chip now, okay, I'll put some power on. I'll put some power on that. There's nothing happening because I need to put the code, the master code, into that 690. Okay. So in a folder I've called control LEDs. Look, there's some demo code. Okay. This is nothing special about this either. Okay. Standard preamble. Okay. For the chip. Okay. And I've told it my target address is 0x40. And you've got to make sure that that's the same as the slave. If it's not the same as the slave, it won't work. Okay. This is going to use software I2C, and you could use anything you like. You can use hardware. I don't care. It's been tested. And why am I using it? Because that's a 690, and a 690 doesn't come with a suitable SSP port. Okay. And in here, we're going to type in live demo. That's exactly the same, just to prove to people it's live. Okay. And I've got some variables, and again, these are just variables left over from previous hacks through this. Right. Okay. I could delete those. Not needed. And basically, I've got the command here. Here it is. Look. It's going to do it forever. So do loop lock, do it forever. I've got a switch on here. Well, I can delete that because that's not needed. It's going to wait 1 second, then it's going to send the packet out. And the packet's made up of a start, a send to my address, which is 0x40. I'm going to make sure it's actually successful, because we could look on the protocol analyzer and see this transaction. Send a 23, and then send an out a variable in here, and then stop. And that variable is going to increment up from 1 to 15, and this is how it increments 1 to 15. That's all it's doing. So what's it going to send out? It's going to send out a packet that looks like this. I'm going to write to device 40. I'm going to send a 23, and in this case it's sending out a note 0x0c, which is set the LED to some value. Right? Okay, right. So it's going to set a couple of bytes in that thing. So compile this up, and this is the master code. The master code will then transmit that packet, this packet, this one, across the bus, and the slave will simply pick it up in the buffer. Okay, so I am going to program this. And why am I programming it? Because it still had IC2 discovery on it. Right? Okay, all right. And my scan is no longer active. Great, it's just compiling up. There we go. Boom, boom, boom. And there we go. Look, you can see these LEDs. Look, they've started up. 2, 8, 9, 10, 11. And so it's all being controlled from here. Because look, if I change this time here, actual fact, this is a bit silly. We'll have more problems seeing it rather than less problems, but never mind. So look, all I've got is a simple bus. And all the handshaking has been done by the libraries. There's a set of libraries which I'll talk about in a moment. There you go, just reset it. Bang, job done. Now you might not believe me actually, in fact. Let me think how we could do this. Look, watch. We're going to take this code here, and we're going to put a repeat in here, and an end repeat. Never do live demos. Oh yeah, I'll do it 4 times. We're going to send, right? We're going to send some values. We're going to send a 0 in here this time, okay? All right. Then we're going to wait 500 milliseconds, and then we're going to send it a 15. And if this works correctly, because the packet, when you're changing the value that's being handled inside the slave, and I'm going to wait for there, and it should do it 4 times, so it should go on and off 4 times. Okay, all right. We'll do it 8 so we can see it. Okay, let's just compile that up. Now this is currently chirping away in here on the screen. It's just compiling it up again. I always have to apologise, my computer's very slow, blah blah blah, because it's doing videoing and other stuff at the moment. So in here we're expecting this thing to go flash flash. Oh, and it is, look. And then it will go back to the counter. Shouldn't have done it 8 times, eh? There we go, look. I haven't obviously set the first value of that, but look, that's working. Pretty simple. So let's look at the slave. Slave's the same, doesn't matter if you use what, this is just the same. All the grunt works inside of this routine. The package, the messages come in, as I said, in this buffer, and you just handle the buffer. What's the it's standard I2C protocol. What you need to add to your program, you need to add in a new include, which is called the message interface. Pretty simple. Okay. As I said, I've redirected this error, and the error handler it just tells you if it's doing a buffer overrun or there's an error on the line. That easy. You just define the buffer size. I've only defined 16 bytes. Nothing. You could make a whole EEPROM using this method. These are a couple of defines for those variables so that it knows where to put the error messages, because it's a user interface. And this here. This lot here, I mean, it's dead easy. Look, this is the standard hardware I2C stuff. You must set this address until it's a slave, and then you have to just put this in on interrupt. When the SSP1's ready, then chuck it out into the handler, and then the handler does all the grunt work. And what you'll return back every time that a packet comes in, you'll be sitting in this particular routine. Whatever you've got running up here, okay, let's be quite frank, don't be running user interface stuff like a big terminal session or anything. It's not meant for that, right? Okay, you do your grunt work. So in here, you can do some other stuff, all right, or you don't need to be quite frank. Depends what you're going to be doing. You can set, read, write, anything. You can collect sensor values, because I'm doing it, I could get the temperature sensor value and send it back to the master, which would be very strange because the master should get the communication itself. But that's really what I wanted to show you. That says, look, it's counting away. Now, let me prove something to you, all right? We're going to go back to this software discovery. I haven't changed this. I have not changed one line in this, okay? All right. Sorry, I'll go back to this. I meant is if I change this address here of 23 to something different, I've changed the protocol. I've changed the packet. The packet will no longer be compliant with this shape. It will have a different number in here. This will not work because the slave is expecting a shape of a packet that looks like it's for me. I'm now a particular slave on X40. I'm looking for 23, and I'm looking for a value to do something with that value. So if you change the protocol in the master, you must change the protocol inside of the slave. Quite clear, they are matched up. Okay, because anything that's coming in, you already know it's only for this slave. It's already all that's been handled. You know that the buffer 0 is going to have the first byte that it was sent. Okay, the first command data byte. And then because of that value has a specific number, you know what to do next, because we know that the next part is actually going to be a value that sets up the port. So it's dead easy. This is really simple stuff, okay, to use. So I wanted a quick ramble through I2C message queues, quickly looking at the code, show you some examples with some values, and it works quite sweetly. I'm very grateful to the guys who did the initial code. All I've done is taken their great work and actually put put a GCP wrap on it. And look, I've just taken out the code and I put that back in just to prove it all works. Okay, and look, I'll disassemble this. Okay, I can take these cables out. It is not hard to set up. Okay, all right, it is really simple. Okay, I've just taken a standard express board, put 2 wires to this what's a PIC Kit 2 low count demo board, and this just works out of the box. Okay, all right. And if I look at the video now in here, I've got nothing happening over here. It's stuck on those LEDs. Why? Because it hasn't got the master software. It does need the master software to make it work. So if I reflash that, we'll see that that will flash a few times for us, like we told it to, 8 times. And if we look on the terminal, we'll see it says live demo, which is where we left it. Okay. Hey, voila. Let's go back. Put it there. Let's call that a wrap.